Okay, this is problem 2, and I decided to do it on a different page because I wanted lots of space to do it. So I'm supposed to analyze and then graph this function. And I'm going to start with all the kind of algebra concepts. So none of the calculus. So that would be like an x-intercept. And then a y-intercept. Then I'll even look for the domain. We'll start with that. To find an x-intercept, I would set the equation equal to 0. And then I like to avoid negatives, so I would add 1 over t to the other side. T to the 4th equals 1 over t. And then I also like to avoid fractions, so I'd multiply both sides by t. T to the 5th equals 1. And then I would do the 5th root of both sides. T equals the 5th root of 1, which is just 1. So if I plug in 0, I get 1 out. So I just have one x-intercept, and it's at 0, 1. To do the y-intercept, I would plug in 0, and that would be 0 to the 4th minus 1 over 0. So 1 divided by 0 is not okay. We can't do that. So that actually doesn't exist, which means there's no y-intercept. Okay, so I have my x-intercept. I know that there isn't a y-intercept. Now to do domain, domain is all the possible inputs, or inputs that have an output associated with them. So I just figured out that x can't equal 0, or I guess actually it's t. T can't equal 0. And then this is sort of an algebra concept that is a little weird, but so t to the 4th minus 1 over t, I could rewrite that as t to the 5th over t minus 1 over t, and then simplify that or combine it to be t to the 5th minus 1 over t. So that's a rational function, and it's being divided by t. So if I plug in 0, like I already know this, that doesn't give me a reasonable output. But there's nothing else that is causing division by 0. There isn't like a t plus 1 or a t plus 2 on the denominator. So 0 is the only problem value. So this 0 that I found for the y-intercept, that's the only one, the only blip in the domain. So the domain would just be negative infinity to 0, and then 0 to infinity. So all of these concepts kind of draw on some things you would have learned in a previous class. So if you have questions about them, please do ask, and I could totally find you videos or clear up any confusion. But let's move on to the calculus part of this. So let's see, let's find the first and second derivative. So if I find the first and second derivative, that will help me with increasing and decreasing and concavity. And actually that should be a t. So my original function was t to the 4th minus 1 over t. Make sure that's right. Yeah, t to the 4th minus 1 over t, which I could also write as t to the 4th minus t to the negative 1th power. So I've rewritten it like that so that it's easier to take a derivative. So the first derivative would be 4t cubed minus, and then minus a 1t, and then minus 2. And so I'm getting that derivative by using the power rule. Then now that I have the first derivative, I can find the second derivative using the power rule again. 4 times 3 is 12. 12t squared, and then minus 2t to the negative 3 power. So both of these I could rewrite if I wanted to, so that they didn't have negative exponents. both our options. Okay, so now that I have the first and second derivative, I want to find the critical points, and I would do that by setting my derivative equal to 0, and in addition to that, by thinking about where the derivative is not defined. So the only place that's a trouble is when we divide by 0, but I already know that t equals 0 is not in the domain, so I don't really need to worry about that. So I'm just going to set it equal to 0 and solve. And I will do that by subtracting 1 over t squared. 4t cubed equals negative 1 over t squared. I'll multiply both sides by t squared. That would be 4t to the 5th equals 1. Oh, and that's a negative 1. Let's not mess that up. And dividing by 4, t to the 5th equals negative 1/4, or t equals the 5th root of negative 1/4. So that right there is my critical point. And now I'll find my possible inflection point. The way to do that is by setting the second derivative equal to 0. And solving. So again, I do need to think about where it's not defined, but the only place that that happens is at when t equals 0, because that's division by 0, and I already knew that wasn't in the domain, so we're good to go. I'm going to start by adding the negative 2t cubed to the other side, and then multiplying both sides by t cubed. That'd be 12t to the 5th equals 2. Dividing by 6, t to the 5th equals 1/6. 2 divided by 12 is the same thing as 1/6. And something seems weird. Oh no, this seems fine. Okay, now I get t equals the 5th root of 1/6. Now, and I'm going to continue this line down. So now I'm going to make number lines. We got the 5th root of negative 1/4. So I need to test points on either side for both of these. And actually, let's pause here and take a minute. If you have any questions, ask them on the discussion board.